Hello dear ones, we are back with the organic sections, that is organic conversion in 2 steps. In earlier episodes we have seen different varieties of conversions, how we can perform, how we can apply the tricks. I'll take a few more conversions with different aspects. The first conversion I would like to take is number 1, that is Benzotrichloride to benzene. Now this conversion obviously we'll do in 2 steps, there is no issue about it. Now what happens, you find a group that is benzene having 3 chlorine atoms, we have named it as benzotrichloride. So little bit you feel as if the compound is so bulky, so difficult, and from there you have to just simply get benzene out of it. You may be feeling little bit uncomfortable, but it is not so. You have to revise your theories, the previous sections of electrophilic substitution reactions, and you can get in no time the answer for the same conversion. See how it works. This is benzotrichloride, benzene having C and Cl3 on it. It is known as benzotrichloride. We'll react this benzotrichloride in such a way that the end product that we obtain is nothing but it is your compound stated over there, and that is benzene. Now it is to be done in 2 steps. So what I'll do, I'll perform hydrolysis reaction of this benzotrichloride with calcium hydroxide and 2 moles water. I'll heat the reaction mixture and accordingly I'll get byproduct HCl. So you are left with carbon, you are performing hydrolysis, actually 3 moles of water, OH combines with the carbon. This is the the mechanisms we have studied in the section of chlorination and oxidation reactions of methyl group of toluene. So refer that if you are having a little bit of hesitation how it is explained, but there it is explained in detail. So here 3 moles of HCl are eliminated on carbon. Now you have C, O and OH, that is now the compound is benzoic acid. And once you get benzoic acid, I have taught you in the previous episode that if you heat it with soda lime, that is mixture of calcium oxide and sodium hydroxide, COO will be eliminated in the form of carbon dioxide, and H will be left, that will combine with the phenyl ring and that will give you benzene. So the compound seems to be heavy one and the obtained or the required compound seems to be simple. Then how can we work? This is the solution you can get by only practicing, and there cannot be any option, but you can have such type of different conversions in your mind, and that helps you a lot during regular studies. I'll take one more, that is benzene to metazylene. Now generally we come across the groups, the position of the groups as meta, ortho and para. We try to think in another way that okay, if it is meta, falana groups are there, if it is ortho, para, so and so groups are there, and so we get onto that track. But there are a few exceptional cases where you don't have to worry much with respect to the existing groups, but there is a protocolic catalyst which will direct the incoming group. I think now you have come to the senses of what I am trying to say. See, we are taking benzene over here and we are willing to have the final product as metazylene. The 2 methyl groups are on the meta position, so that is known as metazylene. This is the initial and the final compound. Fine. Now we have to perform the reaction in such a way that we get an intermediate compound and then we get metazylene. Now what I'll do, I'll first perform the alkylation reaction, that is Friedel-Crafts alkylation reaction with methyl chloride in presence of anhydrous aluminum chloride as a catalyst. Due to that, if I maintain the temperature of about 80 degree or so, automatically HCl will be formed. The mechanisms you have to refer the previous episodes pertaining to the topic, and you will have CH3 on benzene, and that will yield you toluene. Now you may be having the thing in your mind that methyl group is an OP directing group, right? You are absolutely right. Methyl group is definitely an OP directing group, and here we are not requiring ortho and paraxylene, we are requiring metaxylene. You are absolutely right. Now once we require metaxylene, how this methyl group will be able to manage? For that I said a typical reagent, a typical condition is required. Okay, what is that? Say I'll perform methylation reaction, that is again I'll perform the Friedel-Crafts reaction over here with methyl chloride. But the condition I'm going to take over here is not anhydrous AlCl3. If I do so, I'll get ortho and para. That is a simple scenario. But what I'll do, I will change it to HFBF3 as a catalyst, and I'll manage the temperature up to 384 Kelvin. As I do so, what will happen? This HFBF3 are having a directive effect in such a way that the incoming methyl group doesn't get directed on ortho and para that we have discussed during the alkylation, Friedel-Crafts alkylation reaction of toluene. In that I have shown you this exceptional metaxylene case. Do refer that, because right now we are concentrating more on the solvation of conversions, right? Okay, and then the methyl group gets introduced straight away onto the meta position, and so you get metaxylene. So this is an exceptional case where even though the group is OP directing, still we are getting onto the meta. Yes, so that is how you can get metaxylene. Okay, now I'll take one more conversion, that is, I think I should take toluene to benzyl alcohol. This is one more conversion for today. Toluene instead of benzene, we take toluene, benzene containing CH3, as you know it is toluene, and I'll perform a reaction in such a way that the end product of mine should be benzyl alcohol. Benzyl alcohol is benzene having carbon with CH2OH, that is benzyl alcohol. So now I will have to make the things more simpler in my mind, that this is the toluene, this is benzyl alcohol. I want an intermediate compound which will direct to benzyl alcohol. Fine. So what I'll do, I'll perform the chlorination reaction of toluene. Now you may think chlorination reaction, then it is ortho-para. No, I won't do that chlorination, that is electrophilic substitution, but I'll manage with the chlorination oxidation reactions of methyl group. That means the catalyst that I am going to use. See, here also I was talking about the same. The catalyst we use is very important. Here also I'll do the same thing. I'll use a catalyst in a way that it will direct me accordingly the compound that I am wishing to have. So here chlorination is performed, but mind you, it is performed in presence of sunlight and 384 Kelvin temperature. If I would have taken ferric chloride, only then it was an issue of ortho-para, but I changed to the conditions, and that is how I perform chlorination, and as a result, one H from methyl, one Cl from Cl2 combines to form HCl. The Cl combines with CH2 of benzene, and that gives me benzyl chloride. This benzyl chloride, further it can undergo hydrolysis reaction with calcium hydroxide and water molecule, and that will result in the formation of HCl and substitution of OH, which will give me benzyl alcohol. So this is how we can have different conversions with respect to different ideologies, and that is the application we'll be doing with respect to the theories that we have already studied. So prepare well again. See you next time with new episode, and I hope it will be all thorough to you. If you have any questions pertaining to the topic or other than that with respect to some other conversion, do write me a question in the same section or give me an email to styrene, styrene 1411@gmail.com. You are on my YouTube channel Saurin.S.Mehta Chemistry. That is there. Wish you all the very best. Have a nice day.